Hi everyone. Let's explore some problems involving motion and mixing things together and see how we do, okay? Now, our first problem here is going to involve tickets and finding out the number of tickets. And we're going to have my friend here, Newton, here. He's taking his children to the movies, and there's going to be a certain amount of adults that are going to be joining him, and he's going to pay for all the tickets. Now, it so happens that the adult tickets cost $4 and the children's tickets cost $2. And let's let X represent the number of adult tickets. So we're going to find those, and let's say that there's a total of 12 tickets. So we can subtract X from 12 for the children's tickets, and let's say he spends $42 altogether. So we can take the total value of the adult tickets, which is 4X, plus 2 times 12 minus X, which is the total value of the children's tickets, and set it equal to 42. And so we should land up with X equaling 9 tickets, 9 adult tickets. Our next problem involves mixtures concerning maple syrup coming from a tree. Let's say we're going to drain out so much pure maple syrup from a tree, and it's going to fall into this red bucket here. Now we're going to take and add to that some imitation maple syrup, but we don't know how much we're going to add. But we want to add enough so that our total selling price is $5 per liter. Okay, so let's look at what that looks like. We have 50 liters of pure maple syrup at $9.50 a liter, and some imitation maple syrup will represent by X at $4 per liter. So the total mixture is 50 plus X. So to find out what X is, we can take the total value of the mixture, which would be $5 times 50 plus X, equals to the total mixture, or the total imitation, which is 4X, plus 50 times 9.50, which represents the pure mixture. So we set all that equal and work it out, and we get X equals 225 liters. Now our next problem involves Derek on our left here and Newton on our right, and they're traveling towards each other, and they're 1,620 miles apart. And it so happens that Newton is traveling 120 miles per hour faster than Derek. We want to know their speeds when they actually meet. So here's our situation. Newton will represent is 120 plus X, and Derek speed will be represented by X. And let's say it took 1.5 hours for them to actually meet. Well, we can use our distance formula. Distance equals rate times the time to solve for X. So what we're going to do is, since their distances will add up to 1620, let's take the total distance that Newton is traveling, which is 1.5 times 120 plus X, plus 1.5 times X, which is Derek's distance, and set it all equal to 1620. And when we work that down, we'll find out that X equals 480 miles per hour. That's the speed of Derek. And if we add 120 miles per hour to that, we get the speed of Newton, which is 600. Now, in our last problem here involves a sailing ship, and it's going from a harbor to an island. And let's say it leaves at 20 miles per hour, and it takes a time t to get to the island. And let's say that we, on the return trip, he encounters a little bit of wind, so he's traveling at 12 miles per hour. And let's say the total time going and coming is 5 hours. So the return trip's time is going to be 5 minus t. Now, since they're traveling the same distances, we can set the total distance for leaving to be 20t, going to the island, and the total distance coming back as 12 times 5 minus t. Those they cover the same distance going and coming, so we can set them equal to each other. Now we're going to find out what t is, but we want to, in the end here, find out what the distance from the harbor to the island is. So if we calculate this out and find out what t is, then then we can substitute that in for a distance. So we get t equals 1.875 hours. And then now let's say the distance from the harbor to the island, which is d equals 20t, and substitute the t in for that, which is 1.875, and we'll find out that our distance to the island is 37.5 miles.